is everyone doing this morning? Cool, yep, it's super great keynote earlier today. Before we get started, let's do a quick survey. How many of you today are using some sort of AI tools today? Oh, a lot, okay. You are coming to the right sessions. Now, today, I'm gonna talk about this particular thing. Have you seen something like this? Yeah, 5 stages of grief. There's many versions of this, I know. Today, I'm not your psychiatrist. I'm not gonna, if you have anything else, I can help. But this is the version of the LLM. Some of you might say, like, I cannot use AI. This thing cannot do what I like to do. Or perhaps you're trying to make it work. You just like keep giving you the wrong output, hallucinates, and etc. And there may be some of you today that's hoping that you can actually make it work. You start to see some progress, but you need some more help. My goal today is to kind of get everybody to the right side of this, where you can actually using AI to really help your work in the daily basis. So a quick intro. I know a lot of you in the audience today. My name is Welly. I'm part of the AWS team. I work as a principal partner solution architect. I used Terraform before I joined AWS. But then I also have great opportunity to become part of the partnership between AWS and HashiCorp. And then I did AI MLs before we call it generative AI. We used to call it statistic, if then else, and etc. And now I want to study this first. This is a very fast evolving domain. If you just look for the last couple of years from prompt engineering, model fine tuning, for example, RAG, anyone in here using RAG, for example? Some in the audience, yes. Tool use, MCP, is here Armand talking about MCP earlier today, and also multi-agent or agent-to-agent communications. To give you a perspective, just a couple months ago in the spring, I was taking my vacation, and before I took my vacation, I was talking with a lot of folks in AWS about the MCP, and we feel like, hey, this is my going somewhere, but we don't sure yet whether we have the right adoptions, right maturity of the protocol. I went to Singapore for some vacations 3 months back. It all blew up. Everybody talking about MCP, using it in the demos, proof of concept, and etc. So again, we have to really embrace this, that this is a very fast evolving subjects and technology. Now back to the idea like grounding AI into the reality. One of the first challenges that I see a lot when I'm talking with the customer is that they forgot that the context really matters for the LLM. I'm sure some of you already tried this, generate S3 bucket in Terraform. So you provide an input as a human, and then you're using it to ask the LLM to generate the code. Sounds simple enough, right? I mean, what could go wrong? Now, you have to understand that LLM is very eager to please, to give you an answers. Well, for example, in this case, you have no idea about what's the purpose of this S3 bucket, for example. It also have a lot of bias to the training data that's available in the internet. So whatever you see in the blog post in the internet, it's likely gonna show up into the output of your LLM as well. Not only that, it doesn't have any context unless you specify it. It has no context about your projects, your infrastructures, your purpose of this particular request for the LLM, for example. So sharpen your prompt. Sharpen your prompt with more context. One way you can do that is by using RAG, or retrieval augmented generations. And the idea in here is that you pull local files, remote sources, and etc. to help provide more context to the input that you give into the LLM. Let's jump a little bit into RAG. This is not a full AI talk today, so I'm not gonna go too deep into what is RAG and etc. But think about it in this way. You need to transform the word into embeddings. Or the other way I can say it is that transform from sentence and word into a number. New York become a number. Paris become a number, for example. Also animal, horse, and etc. All of these become number embeddings. Why? Because machine likes and prefer number than actual word. So once you have those numbers, you can start to kind of map it into a vector space. In this case, I'm just doing like 3-dimensional space. In reality, this is like a multi-dimensional. And then you can start to see some embeddings and grouping of the similar words, such as wolf, dog, cats, animals, fruits, banana, apples, also book and magazine. And this is great if you are doing some sort of like a correlation of search between book and magazines, or between fruits and banana, for example. Now, if you just take this and put it into, say, Terraform, and then you start to see something like this, right? At the surface, it looks okay, but think about it. If you have an S3 bucket policy or S3 buckets, the next relevance is actually a variable name to that particular bucket, or perhaps the local files or locals reference for these particular S3 buckets. But because it's kind of spread out in the regular rack, if you do a traditional rack, you couldn't pull this information together. So this might impact you in the very early days of AI assistant, for example. But these days, a lot of these AI assistants are going beyond this lexical search. So a lot of these AI assistants today have access to repository structures, your folder structures, for example. You have access to your code, so you can see what's the semantic between the classes and functions, dependency requirements, because you have that AI assistant locally in your IDE, for example. Also your intent, README files, GitHub history, for example, the files that you open. So most of the modern AI assistant today already solving this. So why I'm saying this? Because if you try AI assistant 2 years ago, 16 months ago, you might be not feeling happy about it. I challenge you to try it again, because a lot of these issues has been solved this day with the modern AI assistants. That's one part. So now we have this context. We say, that's great. Let's put this context. This is what's under the hood happen when you send a request to an LLM. There's a system prompt that will append a lot of this context that we mentioned earlier. But even better, if you can be more intentional, say, generate my S3 bucket, and only that, also connect it to my CloudFront distributions. Now the LLM has idea about the repo structures, idea about your intent, and where you want to take these resources to the next level. So even with that, LLM can still hallucinate, right? And for that reason, human execution feedback is very important. One way you can do that is by running a deterministic tool. I run Terraform Validate, or Terraform Init, for example, or Terraform Plan. And the idea in here to see if the resource generated by Terraform, by the LLM itself, actually matches the actual schema of that resources in the provider. Well, the thing in here is that this thing is actually expensive. You gotta be in the loop. You're gonna see the output of the LLM, run, plan, and apply, and keep doing it. So now we are kind of in the middle, yeah? Feeling good a little bit. So we start to think about, how do I use this, right? Instead of like, hey, this is not working for me, it's not generating the right thing, start to kind of hopefully start feeling like there is a way for me to using this. The tool execution that we mentioned earlier are very important. So what if we ask the next questions? What if we tell the LLM itself to use the tool, such as Terraform, or Terraform binary in this case? So instead of you are keep doing this manual work of running Terraform init, plan, and apply for the LLM, you can tell the LLM itself to use the tool such as Terraform to do this. Then you are going to be the final part of this as the human in the loop to review the output of the LLM. So how does LLM today do this? Now, before we have this function calling, and a lot of this new LLM, for example, state-of-the-art LLM today have this functionality. But before that, this is how it looks like under the hood when you call an LLM. There's a system prompt. We mentioned that earlier. You say, hey, what is the attribute for an S3 bucket in Terraform? And the LLM gives you the answers. If you ask the next questions, what's going to happen is that it will append the previous conversations as the context. This is very important. Otherwise, you ask the question, it's like asking the same person, but forgetting about the previous conversations. Now, this itself is great to preserve the context of the conversations. But for the LLM to call another tool, this is what happened. First, you ask another question, what is the default value for encryption in S3? Now, there's two potential paths. LLM will use the training data, maybe it has checkpoint from last year. So it's going to give you answers based on the knowledge that he had at that time, on September last year. Or a lot of this new LLM is configured to say, hey, I can call another tool, Terraform registry function. And then you give that output to the LLM application. This is the chatbot that you're potentially using, the CLI, for example. And then that CLI itself is the one making a call to the Terraform registry, for example, to retrieve the schema, for example, of the S3 bucket and return it back to the LLM. So now the LLM itself has access to the new informations, and it can give you more recent informations. And that really changed the game, right? So here's some example of the tool LLM that you can do. You can run static analysis, Terraform validate, Terraform plan, checkoff, Sentinel, policy as code. You can use it to retrieve information from the external source, wiki, or even like other API for like observability API and etc. And then you could build your own function to do this, especially if you have internal database that you need to retrieve as additional informations. And as much as you can, try to use a standard protocol such as MCP. So the next question will be like, what is MCP? Today, one of my colleagues, Manu, will be talking more about what is MCP. Also, there is a session with Gautam. But just in the simple terms, I don't use this. This is one of the blog posts. I highly encourage you to look at it as well. MCP is potentially, you can think about it as a USB for your LLM. So you can use this, for example, to connect any LLM to any tools using a standard interface. So now, you can use this in the bigger context. Earlier, we say about prompt and enrich your prompt with more intent, more context from the rack. Now you can also tell the LLM to go and retrieve live information, for example, by using the MCP server to retrieve information from Terraform registry. You can also ask LLM to generate the code and then also do tool execution to verify the result of that particular code that is generated before you as the final human to review it. So this brings us to the final part. Let's figure out how we can use this. Like a lot of this concept that we learned earlier about the rack, the tool executions, additional context that you can use, allows you to really go beyond just chatting with the chatbot, for example. And in here, we think about AI as this system that's getting better and better at instructing other AI. So what does that mean? A lot of these experiments in the early years is all about rule-based executions. You have predefined rules of what to do and etc., if then else, and you have some sort of agentic work perhaps running in there, which kind of called like a low agency agentic use cases. And then there's this generative AI assistant. Some of you might be using it as well. We have a lot of demos in AWS booth. You can go and take a look at it as well. This is where you can use it to achieve specific goal. But really what we want to be is on those high agency with less human oversights. This is where you have agents that just sit there silently and look at for open tickets, Jira ticket, GitHub issues, and go and start to poke and research and then try to troubleshoot those issues. So a really good agentic AI ideally have this kind of concept around plan and perceive of the information that is given, right? Also do additional research to find more information, and then using that to perform planning, decide what it needs to do, and then take actions by using the tool executions and etc. And not only that, it should be able to learn, say, comes to the mistake, whether that's because hallucinations and etc., and remember and improve itself. So this is just one example of it. You can have this specialized agent that works as the orchestrator to other more deterministic and more specialized agent on specific use case. So you could have human to provide specific tasks. You have this orchestrator agent that then talk with another sub-agents, whether this sub-agent is doing code generation, scanning, migration of code, and etc. Each one of them has its own tool, and then you can use it to do planning, reasoning, executions, and etc. So the next question will be like, okay, what are some good examples of this? So this is a real use cases that we do here at AWS. Some of you might be familiar with AWS Cloud Control Provider. This is automatically generated from the schema that published by AWS. And because it's fully automated, it also means like by the time we release something, we just publish everything to the registry, but there is no human creation of code examples and how to use these resources. And we have a group of people inside of AWS and also volunteer from the open source that are doing this. Research for specific feature and services in AWS that just launched. And that typically takes 1 or 2 days. And if you're lucky, you're already an expert on that area, maybe networking and etc. So you may be more familiar. If not, it will take more time. So we come up with this idea, we call it Tango. It's a Terraform AI native generator and orchestrator. This is actually a summer internship project by one of our AWS interns. Her name is Ekaterina. She's not here today with us in San Francisco, but very kudos to her. And this agent, we're going to orchestrate, do research, write a code and test, and then prepare a pull request that then we can submit to the AWS CC provider repository. What's the result? Over the whole part of this project, we have done multiple iterations of this. We have generated over 500 resources, code example for those resources. And the average cost to run the inference of the LLM and everything else for these particular agents are about $5 per resources. If you compare that with like 1 or 2 days worth of work of human to review this and then do the analysis and then write the code, this is very where you can say like, this is how we scale using AI to do your work, right? So we're going to show some sample of the code and demo later on. Just going to set the ground of what the architecture of these agents. So this agent in here comes with the orchestrator that then will have a sub-agent, such as the discovery agent. This discovery agent can go and look at the GitHub repo, also have access to no-code, NoSQL database such as Amazon DynamoDB. So it can store the information and memory about the executions. The documentation agents can retrieve information from Terraform registry and AWS documentations. The Terraform agent is the one that actually writing the code, running a test, and etc. And then we'll talk more about the validation agent. This is what we call have the other LLM to grade the work of the first LLM. And this is important to ensure there is no bias about the work done by one agent to be graded by another agent. And then, of course, you might have additional agent to do a cleanup, storage, and etc. So now let's come to the demo. Before you watch the demo itself, there's multiple parts of that architecture. Because of the time we have today, we're going to focus only on 3 parts. First one is the documentation agents that I mentioned earlier. This is where you're going to do some research. Then there's the agent that will write the actual Terraform itself, do some tests. And finally, we have this LLM as a judge, which is another validation agent that will grade the output of the previous one. So let's take a look at the demo. So the first part in here is the documentation agents. I asked it to create a resource example for EC2 network insight analysis. This is a new resource that was published a couple of weeks ago, and I don't have any knowledge about these resources. So the first thing that the agent does, for example, in here, is to retrieve more information about this particular AWS services, feature, and the resource. The way it does that is by going to AWS documentations to retrieve information. Because you give it access to the internet through like an API call or HTTP call, it can go and make a call to the AWS documentations. You can also ask it to go to the Terraform registry to pull the information about the schema of the resources. So now it has two information, the AWS documentations and also the registry to see what's the attribute of the resources. And then it passed that information to the second agent. This is what the role of the orchestrator. It takes the input of, from one instructions and give it to the next one. And now you can see in here, this agent start to write the code itself. And then as you writing the code, it kind of does internal reflection to see, hey, is there anything else I can do to optimize the code? So it goes through that motion, just like you as a human kind of writing a code, right? You have one person and the second person and etc. So in here, it starts to write those configurations. And you can see some sample specific of that as well. For example, like it's specifying like the AWS provider versions, the network inside path require additional dependency, for example, specific VPC network and etc. And then it's going to use that information to run plan and apply as well. Because this is important. We don't want the agent to just write the code. We want the agent to actually do some tests. Remember, we mentioned about the tool execution earlier. So this is where it's going to do that. So now this agent is going to run Terraform init. Again, we recorded this as part of the CLI, but in reality, this agent running behind the scenes. There's no human interactions. So the first thing the agent will do is to run Terraform validate. Just check the schema, making sure everything is good. When it knows that the configuration are valid, of course, what's the next thing you want to do? You want to run Terraform plan. And after you're done with the Terraform plan, the next thing you want to do is to run Terraform apply, right? And as you can see in here, you're going to see output from the real-life executions, where it might actually fail because there are certain dependency, certain network resources or attribute that is wrong. And it's going to go in live to actually make those fixes as well. So in here, see there's an issues with this specific attribute about the source and destinations, and it's trying to make those changes as well. So you're going to go through these iterations, essentially, to keep doing the test, plan, and apply, just like you as a human, if you face with the similar issues, right? Now, at the end of it, we also want to making sure it clean up. So it's clean up the resources that it created. And the way we do this is that we provide this secure AWS environment for this agent to run, so it have access to credential in this secure environment to run the test and experiment itself. So now what we're seeing in here is that we're just waiting for this agent to complete the destroying of the resources. Now, once this is done, the next thing we have to do is to have another LLM to judge the result of this LLM, right? So this is the part of we have the next LLM to judge the result of it. And the way we do this is that we ask this second LLM to judge, one is the validity of the code. So it's going to ask this validation agent to run another plan and apply to verify everything that the other agents say is actually complete. And this is important because you want to avoid any kind of hallucination, because sometimes, as I mentioned earlier, LLM can be very optimistic, even though the plan and apply not success. You say, everything is good, you can test this in the live. This is what we want to try to avoid by having another LLM to do as the judge. So this LLM in here is pretty much doing the same thing in here, such as making sure like the plan and apply works correctly. And then it also allows you to add additional checks. You can say, hey, what is the writing style of this particular LLM? Does it fit to your organization needs? Maybe you have specific way about like, I want to use local with nested locals and etc. You may have like camel case, snake case for your variables and etc. This is also the time when you can have this additional review to say, are this code written by LLM is actually meet my requirements? Just like you have like a pull request review and body system. That's just one example of the use cases for using agentic work. There are many other use cases, and I highly encourage you to kind of look and explore in this, from using it to develop a code, do code migrations, for example, security compliance, for example, policy as code, or even having like some sort of observability agents that can help you triage some issues. All right, key takeaways. Your prompt is your intellectual property. This is very important. what you're going to see in the next coming months is that you come again to another conference, you're going to ask, hey, dude, how you get that? Can you show me a sample of your prompt? Because we kind of move that intellectual property from the code that you written to the prompt that you given to the LLM. The other thing is that use this new technology, tool executions, tool use, reflections, to allow this LLM to kind of self-improve themselves and have yourself as the human in the review, human review in the loop. And finally, find that high value, high impact works. A lot of things that happening in your organizations that you feel can be automated through the use of the LLM. Because the more high agency works that you can do is likely where you're going to find the best value of using LLM. We have so much to cover today. The good news is that there are more sessions about this. Manu will be talking with the team from HashiCorp about how you can use AI more deeply into the Terraform use cases at 2:45. And then Gautam will talk more about the Terraform MCP just right after that. So highly encourage you to check it out. And if you're interested with the sample code that I showed earlier, this is the QR code. Feel free to take a look at it, and maybe you can experiment with it. We'd love to hear your feedback. We'll continue to improve this sample code as well. And finally, thanks so much for being here. Really appreciate the time. And then if you have any questions, feel free to reach out to me. We're going to be somewhere around the hall. So thank you so much.